Hi, we can discuss about arithmetic logic unit. So what is actually ALU? It is a digital circuit that performs both arithmetic and logical operations. So ALU is the main part of central processing unit. It performs both arithmetic operations as well as logical operations. This ALU has a number of selection lines to select a particular operations in the unit, because ALU performs various operations and at a time one operation has to be selected. For that, the ALU has a number of selection lines or select lines. So if ALU has k selection lines, it can implement 2 raised to k distinct operations. K number of selection lines ALU ഉണ്ടെങ്കിൽ ആ ALU വെച്ച് നമുക്ക് 2 raised to k operationsനെ distinct operationsനെ implement ചെയ്യാം. So ALU, it is the main component of a central processing unit. It has selection lines to select various operations. If it has a k selection variable or k selection lines, it can implement 2 raised to k distinct operations. And this is the block diagram of a 4-bit ALU. So 4-bit ALU block diagram. It has 2 input. One is A and the other is B, each of which is 4-bit in nature, and it produces a 4-bit output. Along with this, 3 selection variables are there. One is S0, second one S1, and third one S2. Here S0 and S1, they are function selection variables or selection lines, and S2 is a mode select. So there are 2 inputs, each of which is 4-bit in size. A input is there, also B input is there. A is a 4-bit input, B is also a 4-bit input. Okay, and it produces a 4-bit output. Output is F. Okay, F1, F2, F3, F4 are the bits of output. Okay, along with this input and output, another inputs are the first category is selection lines. How many selection lines are there? 3 selection lines are there. One is S0, other one S1 and S2. And what is S0 and S1? They are function select, and S2 is mode select. Along with, there is an input carry C in as well as an output carry C out. This is the block diagram of ALU. So the figure shows a block diagram of a 4-bit ALU. Here 4 data input from A is combined with B to generate output. S2 is a mode select input. S1 and S0 are the 2 function select, and there is an input carry as well as output carry. So this is the block diagram of ALU, a 4-bit ALU. So actually ALU, they are used for implementing both arithmetic and logical micro operations. So arithmetic circuit is there as well as logic circuit is there for implementing an ALU, right? So how to design arithmetic part for implementing arithmetic operations? So ALU എന്ന് പറയുന്നത് arithmetic സെക്ഷനും വർക്ക് ചെയ്യണം, അതുപോലെ ലോജിക്കൽ സെക്ഷനും ലോജിക്കൽ ഓപ്പറേഷൻസും അവിടെ ഇംപ്ലിമെൻറ്റ് ചെയ്യണം. അപ്പോൾ രണ്ട് ടൈപ്പ് സർക്യൂട്ട്സ് കമ്പൈൻ ചെയ്തതാണ് actually this ALU. Okay, that circuits are, one is arithmetic circuit and other one is logic circuit. Okay, first how to design arithmetic circuit. So what is the basic component of an arithmetic circuit? So basic component means it has to perform basic operations. So what are the basic arithmetic operations? Add, subtract, division, multiplication, etc. For that, so the basic component of an arithmetic circuit is a parallel adder. Okay, so next figure which demonstrates the arithmetic operations obtaining when one set of inputs to a parallel adder is controlled externally. So this is the figure which shows how to implement the arithmetic operations or different types of arithmetic operations by using parallel adder. We have here addition with carry, addition with ones complement, transfer A, how to implement increment and decrement functions, etc. So here there are 8 operations that are implemented by using a parallel adder. So for a parallel adder we have 2 inputs A and B, along with one input carry is the outputs are one C out as well as original output, that is F. So by using parallel adder we can implement all these types of operations. So basic component of a arithmetic circuit is a parallel adder. Okay. And this is the logic diagram of arithmetic circuit. Actually it is a 4-bit arithmetic circuit that performs 8 arithmetic operations. So inputs are A and B, which are of 4-bit in size. Along with this input there are 2 selection variables are the S0 and S1, and other input is carry in. By using NOT gate, AND gate and OR gate along with full adders or parallel adders, we can implement 8 operations, arithmetic operations. Clear? So the design of a 4-bit arithmetic circuit that performs 8 arithmetic operations shown here in that figure. And all these arithmetic operations are listed in next table. So based on S0, S1 and Cin function, Cin input, we can implement 8 arithmetic operations. If S0, S1 and Cin value is 0, it implements a function that is transfer A. Whatever is the input A, that is the output F. If a combination S1, S0, Cin is 0, 0, 1, then it is an increment operation. If S1, S0, Cin is 1, 1, 0, then it is a decrement operation. So ALU, it is a combination of both arithmetic circuit and logic circuit. How to implement this arithmetic circuit? By using adders. So here is an example of a 4-bit arithmetic circuit which implements 8 operations by using NOT, AND, OR gates along with 4 full adders. Why we are using 4 full adders here? We have to implement a 4-bit arithmetic circuit. So 1 full adder for 1 bit. Okay. So nammalippom ALUവിന് രണ്ട് പാർട്ടാണ്. അരിത്തമെറ്റിക് സർക്യൂട്ടും ഉണ്ട്, ലോജിക്കൽ സർക്യൂട്ട് ഉണ്ട്. സോ അരിത്തമെറ്റിക് സർക്യൂട്ട് എങ്ങനെ ഇംപ്ലിമെൻറ്റ് ചെയ്യും? ബൈ യൂസിങ് ആഡേഴ്സ് ആണ്. സോ 4 ബിറ്റ് അരിത്തമെറ്റിക് സർക്യൂട്ടാണ് നമുക്ക് ഇംപ്ലിമെൻറ്റ് ചെയ്യേണ്ടത് ഫോർ പെർഫോമിങ് 8 അരിത്തമെറ്റിക് ഓപ്പറേഷൻസ്. സോ 4 ഫുൾ ആഡേഴ്സ് ആവശ്യമുണ്ട്. ഒരു ഫുൾ ആഡറിൽ ഒരു 1 ബിറ്റ് ഓപ്പറേഷനാണ് പെർഫോം ചെയ്യുന്നത്. ഓക്കെ, A1 B1 അഡീഷൻ ആണെങ്കിൽ അത് ആഡ് ചെയ്യപ്പെടും. സെക്കൻഡ് ഫുൾ ആഡറിൽ A2 B2 ആഡ് ചെയ്യപ്പെടും. ക്ലിയർ? സോ ദിസ് ഈസ് അബൌട്ട് അരിത്തമെറ്റിക് സർക്യൂട്ട്. So next part of ALU is a logic circuit, right? So what is the use of this logic circuit? For implementing logical micro operations or logic micro operations. Which are they? And, or, not and XOR are the 4 basic logic operations. For that, in logic circuit we are using 2 selection lines, S0 and S1. So this is the architecture of a logic circuit. It is the simplest way to implement a logic circuit. So here 4 gates are there. One is OR gate, XOR gate, AND gate and NOT gate. And the inputs are common. AI and BI are the inputs. So at a time, one operation is to be selected. Clear? For that we are using a mux. All the gates outputs are connected to mux. So we have to select one operation output from the mux by using 2 selection variables. Which are they? S0 and S1. So by using the combination of S0 and S1 we can select each one of the operations. If S1 S0 combination is 0 0, then it will implement an OR operation. That means OR gate is active. All others are in an inactive state. If S1 S0 is 0 1, then it will implement a XOR operations. So OR gate, AND gate and NOT gate are inactive state, and XOR is active state. Then next combination S1 S0 1 0. Then it is a AND operation. 1 1 combination means it is a NOT operation. So these are all about logic circuit. So ALU, 2 parts are there. One is arithmetic circuit and other one is logical circuit. By using parallel adders along with some gates, we can implement arithmetic circuit. Also we can implement logic circuits by using mux and basic gates. Clear? Next we have to combine both the circuits, that is arithmetic circuit as well as logic circuit. For what? For implementing or for building ALU. So design of arithmetic and logical circuit and logic circuits. So logic circuits can be combined with arithmetic circuit to produce a one ALU. So in both arithmetic circuit as well as in logic circuit, we are using 2 selection variables, right? S0 and S1. And what is the use of these 2 selection variables or selection lines? For selecting distinct operation. Clear? So in ALU, there will be an arithmetic part as well as logic part. So S0 and S1 can be made common to both sections, and we can use a third selection variable, that is a mode select variable, S2. Why we are using S2 as a mode select? We can select mode. Which mode? Arithmetic mode or logic mode. Clear? So ALUവിന് 2 component, arithmetic circuit part ഉണ്ട്, logic part ഉണ്ട്. രണ്ടും എങ്ങനെ ഇംപ്ലിമെന്റ് ചെയ്യുന്നത് നമ്മൾ നോക്കി. ഇനി നമ്മൾ അതിനെ എന്ത് ചെയ്യണം? കമ്പൈൻ ചെയ്ത് ALU ആക്കണം. സോ 2 പാർട്ട്, arithmetic പാർട്ട് നോക്കുമ്പോഴും ലോജിക് പാർട്ട് നോക്കുമ്പോഴും നമ്മൾ രണ്ട് സെലക്ഷൻ വേരിയബിൾ അവിടെ കോമൺ ആയിട്ട് യൂസ് ചെയ്തിട്ടുണ്ട്, S0 S1. സോ ALUയിലും നമുക്ക് രണ്ട് സെലക്ഷൻ വേരിയബിൾസേ യൂസ് ചെയ്യേണ്ടു, S0 ആൻഡ് S1. അത് ഡിഫറെൻറ്റ് ഓപ്പറേഷൻസിനെ സെലക്ട് ചെയ്യാനാണ്. അതായത് ലോജിക്കൽ ഓപ്പറേഷൻ, ഓർ അതിനെ സെലക്ട് ചെയ്യാൻ വേണ്ടിയിട്ട് ഒരു കോമ്പിനേഷൻ, ആൻഡ് അതിനെ സെലക്ട് ചെയ്യാൻ വേണ്ടി വേറൊരു കോമ്പിനേഷൻ. ലൈക്ക് വൈസ് നമുക്ക് അരിത്തമെറ്റിക്കിലും S0 S1 യൂസ് ചെയ്ത് ഡിസ്റ്റിങ്ക്റ്റ് ഓപ്പറേഷൻസിനെ നമുക്ക് സെലക്ട് ചെയ്യാം. ഇനി ALU ഇപ്പോൾ വർക്ക് ചെയ്യുന്നത് അരിത്തമെറ്റിക് പോർഷൻ ആണ് അല്ലെങ്കിൽ ലോജിക്കൽ പോർഷൻ ആണെന്ന് നമുക്ക് മനസ്സിലാവണം. അതിന് വേണ്ടിയിട്ട് എന്ത് ചെയ്യണം? ആ മോഡ് സെലക്ട് ചെയ്യാൻ അരിത്തമെറ്റിക് ഓപ്പറേഷൻ ആണോ അല്ലെങ്കിൽ ലോജിക്കൽ ഓപ്പറേഷൻ ആണോ ഇംപ്ലിമെൻറ്റ് ചെയ്യേണ്ടത്, അത് സെലക്ട് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് നമുക്ക് അടുത്ത സെലക്ഷൻ വേരിയബിൾ ആയ S2, അതാണ് മോഡ് സെലക്ഷൻ എന്ന് പറയുന്നത്. സോ S2 എന്ന് പറയുന്നത് ആക്റ്റീവ് ആയാൽ, ഇപ്പോൾ 1 ആണെങ്കിൽ it will indicate it is an arithmetic operation. S2 is equal to 0 means it will indicate a logic operation. Clear? ഇനി S2 is equal to 1, അതൊരു arithmetic operation ആണെന്ന് മനസ്സിലായി. ഇനി ആ arithmetic operationൽ ഏത് ഓപ്പറേഷൻ ആണെന്ന് മനസ്സിലാവുന്നത് എങ്ങനെയാ? By using S0 and S1. Clear? So this is illustrated in another figure, that is we can combine logic and arithmetic circuit. So one stage of arithmetic circuit is there, one stage of logic circuit is there. So common to both these circuits we have AI input, BI input and S0 and S1. S2 which is connected to MUX. What is the use of MUX here? Multiplexer which selects arithmetic portion or a logic portion at a time. For that we are using third selection variable, that is S2. That means S2 is equal to 0, it is an arithmetic circuit is selected. S2 is equal to 1 means its logic circuit is selected. And there is another input, that is Cin. That is only for arithmetic circuit because it's a carry in input. Clear? So this is actually ALU. So this is the truth table that shows 4 logic operations in an ALU. We already discussed. Next, how to design arithmetic and logic circuit. Actually, there's a ALU. It is used for performing arithmetic and logical operations. It is the main component of the central processing unit. And this is the logic diagram of ALU. That means here there is an arithmetic part as well as a logic part. So we can implement both arithmetic operations as well as logical operations. Inputs are AI and BI. 2 full adders are there, and also 2 selection variables, S0 and S1. And one mode select variable is the S2, and there is also a carry in input. That means by using this logic diagram we can implement 8 arithmetic operations as well as 4 logical operations. And there are 3 selection variables, S2, S1 and S0. S2 is the mode select, S1 and S0 are the function select. First, steps involved in the design of ALU. First, you design the arithmetic section. It is independent of logic section. And second, determine the logical operations obtained from arithmetic circuit and modify this arithmetic circuit to obtain the required logical operations. So these are the steps that is involved in the design of ALU. So this is the truth table, that is for implementing 8 arithmetic operations as well as 4 logical operations by using a 4-bit ALU. Okay, that means when the combination is S2, S1, S0, Cin, all are 0 means the function is a transfer function. If the combination is 0, 0, 0, 1, it is an increment operation. If the combination is 0, 0, 1, 0, it is an addition operation. If it is 1 0 0, a don't care condition, X represents a don't care condition, it is an OR, that is logical OR operation. If the combination is 1 0 1 don't care, it is an XOR operation. Likewise, this is the truth table for a 4-bit ALU for implementing 8 arithmetic operations as well as 4 logic operations. Okay. So these are all about the design of ALU. So first we have to design arithmetic part, then logical part, modified and combined to form ALU. Clear? And the next and the final portion of module 5, accumulator and the design of accumulator. So actually we had already discussed about accumulator in last class. What is actually accumulator? It is a register, or it is a processor register, or otherwise we can say it is a multi-purpose register. It is different from other processor register. We can call it as accumulator register because it accumulates the results. Okay. In a computer's central processing unit, an accumulator is a register in which intermediate arithmetic and logic results are stored. So for storing intermediate results, we can use this accumulator. Okay. So this is the block diagram of an accumulator that forms a sequential circuit. So register A, it is combined with a combinational circuit to accumulate intermediate results. So the register A is associated with a combinational circuit constitute a sequential circuit. Okay. And the combinational circuit replaces the ALU but can't be separated from the register since it's only the combinational circuit part of sequential circuit. So here register A is referred to as the accumulator register and it is sometimes defined by the symbol AC. Okay. And the accumulator can perform the functions like parallel load, shift operations, counting, data processing operations, etc. So actually it is a multifunction register that by itself it can made to perform all of the micro operations in a processing unit. Clear? So the set of micro operations that is present in accumulator, or the accumulator which can be used for this set of micro operations for implementing add, clear, complement and etc. operations and shift operation, logical operations can be implemented by using the accumulator register. So the set of micro operations are generated by control logic circuits and considered as the control functions to initiate corresponding register transfer operation. And register A is the source register in all the listed micro operations, and register B, it is the second source register. Here destination register is always register A. Register A stands for accumulator register. So these are all about accumulator. Clear? So in this class we had discussed about what is ALU, what are the design features of ALU, next what is accumulator, how to design a accumulator. Only the basic parameters we had discussed here. Thank you.